Hey, we have here today another integral. This one's from MIT Integration Bee 2022. This was from regular season, problem number 8. We have the integral of x plus sine x over 1 plus cos x dx. I think I'll fix that dx. The problem that jumped out at me first is it's tricky to have an x. It's hard to integrate and mix trig functions with just an x. So this looks like a problem. But I also noticed this thing, sine over 1 plus cosine x. This is actually an identity. This value is the same thing as tan of x over 2. So I think how I'll start this off is if I split this into two integrals, one of them is going to be just tan of x over 2, and that other integral is going to be easy to deal with because we know how to integrate this. Okay, so now I've split this into two integrals, and we've changed this over to tan of x over 2. And if you're not familiar with this, let's just go over real quick how we got this value. So we have these two double angle formulas here for sine and cosine over here on the right. And what we can do is with just a little adjustment, we can use these. So what I can do is, if the angle is 2x, this is equal to 2 sine x cos x. Well, what I can do is, if we have that, when the angle is just sine of x, we can write this as 2 sine x over 2 cosine x over 2. And then we can do basically the same thing with cosine. So when the angle in here, if you input x over 2 here, you just have x. So cosine of x is going to be the same thing as 2 cosine squared x over 2 minus 1. So then for our expression, sine x over 1 plus cos x, we'll just use these values that we found here. So for sine x, we'll use 2 sine x over 2 cos x over 2 over 1 plus, and for cosine x, we'll use 2 cosine squared x over 2 minus 1. Well, 1 minus 1 is 0. The 2's will cancel here. We can cancel a cosine with one cosine, and what are we left with? We're just left with sine x over 2 over cosine x over 2, which is just the same thing as tan x over 2. So now what I want to do is let's just get back to this integral because again, this is solvable, but we want to know how do we deal with this? Well, what I'm going to do is stay with these half angle formulas and use our formula down here for cosine. Just plug that in right here. So we'll leave our x as it is. Then we're going to have 1 plus this value, which is 2 cosine squared x over 2 minus 1. Again, 1 minus 1 is 0. I could take this 2 and bring it into the numerator. We can write this as x over 2. And then cosine's in the denominator, so we can write this as secant squared x over 2 dx. And now this integral is not too bad because we know how to integrate this and we know how to differentiate this. So I think this is going to be a perfect case for integration by parts. I'll use the DI method or tabular integration. And what I'm going to do is we'll differentiate, like I said, x over 2. We'll integrate secant squared x over 2. Let's just do this real quick. So derivative of x over 2 is just going to be 1/2. Integral here, this is going to be tan x over 2. But we have a half. We put that in the numerator. We have to bring out a 2. So we're going to have part of our solution right here. Multiplying this together, 2 times x over 2 is just going to give us x times tan x over 2. That's nice. Then we're going to have this integral. Okay, we're going to have, again, 2 times half is going to be 1. So we're going to have integral minus tan x over 2. And so of course we could integrate this, but we actually don't have to because we have this up here and we could just kind of bring that down into our solution. So we're adding this integral, so we're adding tan x over 2 dx. This is exactly this. So this is going to cancel. So we're left with our solution being x tan x over 2. Now one quick note on this, if you don't like having your answer with a half angle, we can put it back into full angle. We can put it back into this form. So we'll have our x, but we know the value for tan x over 2 is going to be this. So we'll have sine x over 1 plus cosine x plus c. And so this also would be a valid solution. I thought the funny thing with this is look at the similarity to our original integral. So if the first thing I did was just remove this plus sign right here, we would have had our solution in like 1 second. So next time I'll do it that way. Anyway, thanks everyone for watching today. Please like and subscribe. Have a good day.